I'm sure I have one of these from last year, so I'll have the whole thing if there's anyone who's actually away today. Okay, so even though most of the atom is, what's most of the atom made of? Empty space. Because sometimes they are seeing things bouncing back, but it only happens every once in a while. So is the thing they're bouncing off very small or very big? Very small. See, you guys are genius scientists, right? And do you think if it's bouncing off it, is it hard or soft? It's hard. So there's something very small and hard inside each atom. Okay? And now we're going to watch Tyler again because he's going to talk about this. Oh, this is a nice picture. So we've got a top-down view of the atom. Most of the atom is empty space, so most of the alpha particles go straight through. However, we have something very small and very hard inside the atoms, and when an alpha particle hits them, they veer off to the side or they bounce back. And if we take those two models together, where most of the alpha particles are going straight through, and then the few where they're bouncing off, and we combine them together, we get a picture that looks like that. Yeah, where most of the alpha particles are going straight through, but every once in a while, some of them bounce back or veer off to the side.
And his team are able to make some conclusions about what the atom actually looks like. Here's the conclusions that they come to. Let's start with this gold foil, okay? The gold foil that they use is incredibly, incredibly thin. And in fact, it's so thin that these guys reason that there are only a few atoms in its thickness, that it's only a few atoms thick. So let's look at it on its side here and look at a magnified view of the gold foil. If we want to think about gold atoms as being sort of circles or balls, this is what the view from the side of the gold foil might look like.
So it's basically, in his little model here, it's only about 2 atoms thick, okay?
Just 2 atoms thick here. Now, let's think about the results that they got from the gold foil experiment, okay? The first thing that they saw is that most of the time, the alpha particles seem to have gone straight through the gold foil. So, based on this information, they're able to reason that most of the atom is empty space, or if there's something there, it's very light. It's not very dense, and it's really easy for the alpha particles to shoot right through. So most of the atom is probably empty space. But now the second thing they see is that every once in a while, an alpha particle, zoom, veers off to the side, or it's like it hits the gold foil and bounces back. And so based on this information, they reason that while most of the atom is probably empty space, they think that there must be something very small but very hard inside each atom. And here's a drawing here. Of course, you know that this is the nucleus now, but they didn't know that the nucleus existed, so they had to discover it here. And so they think there must be something really, really hard. And when an alpha particle hits it head on, bam, that alpha particle's gonna ricochet back. And they also notice, as we said, that sometimes the alpha particle veers to the side. They say, well, maybe it's because it hits the nucleus on the side of it, so it goes off like that.
Question. What charge are alpha particles? Positive. Now, if this is a positive particle, and this is that little small hard thing in the middle of the atom, and this is my alpha particle, and it comes along here, this is positive, and it goes, what probably charges this? If it was negative and this was positive, they would go, right? Because positive and negative attract. But if it's positive and it goes, what charges this? Positive. So that's how they figured out that probably this little small hard thing in the center of the nucleus, in the center of the atom is positively charged.
Or they also said maybe since alpha particles are positively charged, maybe the nucleus is positively charged, so that if the alpha particle comes close to it, remember, things that have the same charge repel each other. So you've got this alpha particle coming close to a positively charged nucleus, then zoom, it's going to veer off to the side because they're pushing away from each other. So regardless, based on this information, they reason that there is something small and hard in the atoms that once in a while the alpha particles are banging into, and that's what's causing them to bounce back or to veer off course. And they also reason that whatever this nucleus is made of, it's probably positively charged because of the way it looks like the alpha particles are sometimes getting repelled and pushed away. So if you take these two pieces of information together, we can come up with a model for the atom that looks like this, where this is just a combination of those two things that I saw, where we've got these gold atoms lined up, and most of the time, if alpha particles pass through so they don't hit any nucleus here, they just go straight on through. But if an alpha particle hits this hard, dense nucleus, or is close enough to be repelled by its charge, it veers off or it bounces back. So here's how the gold foil experiment changes how scientists think about the atom. Okay, so as we said before, here's a plum pudding atom with these electrons stuck in a positively charged kind of pudding. But Rutherford's experiment shows that this isn't quite true. Instead, he comes up with a model like this, where there is a hard, dense nucleus in the middle, and that is where the positive charge is. So the positive charge isn't like this kind of blueberry muffin dough that's spread throughout the atom, but instead the positive charge, everything that I've drawn in red here, the positive charge is concentrated right here in the middle of the atom, and then there might be some electrons floating around on the outside, but they're certainly not held in place because of the positively charged dough. Now, this is just one piece in a puzzle of figuring out what the atom actually looks like. So shortly thereafter, Rutherford comes up with this model for the atom, but then scientists realize that the electrons probably aren't just stuck in place, and instead they think that the electrons are spinning around the outside of the atom, and you still have this hard, dense nucleus in the middle. And then only a short while after this, it's discovered that the nucleus isn't just a hard piece of positive charge, but that the nucleus is actually made of protons, each one of which has a positive charge.
And then later on, they discovered the neutrons. Okay, and this is probably all we're going to get through for today. I think now would be a really good time to do a parking lot walk while it's still nice. Okay, and then we're going to come back and we're going to work on pages 15, 18, 19, and 20, 15, 18, 19, and 20. I'm also going to give you a practice quiz because what do you have tomorrow? You have the quiz. And I know you drew things over the weekend, but a lot of people didn't label them because it didn't say to label them. I'm sorry, I need to fix that in the workbook. But the practice quiz does say to label them. So I'm going to give you those pages plus the practice quiz. But let's go walk around the parking lot first. This is sunny, and we might as well enjoy the sunshine before it starts raining again. All right, folks, let's go. Let's go. Okay, yes. Yes.
So my dad was telling me we were watching Oppenheimer,
Uh-huh.
and then he was talking about like because he like studied physics and
Oh, yeah.
so he was talking about like music physics. It's like a mix of physics and chemistry.
Okay.
Yeah, I was just wondering if you like knew about it.
I don't, but I should look it up, shouldn't I?
So I searched that and there was nothing, so I was wondering if it's like
Plus the practice quiz.
two types of people out.
Okay, let me find that practice quiz for you guys. Oh, here we go. If I had been really smart, I would have put it on the front and the back. But you can just do it on the back for yourself. Yeah? If you want to.
Yeah, you can. So open it. But do it. Yeah, that's fine. First person to propose the concept of
What page are you at?
What pages are you not on 15?
Oh, we're doing 15. Yeah. The quiz will look exactly like this practice quiz. Okay? So there will be no surprises.
Yeah. All atoms have smaller atoms. What?
I don't think you mentioned that.
Yeah, dude. I don't know.
No,
Everybody wants it.
practice is just practice.
Wait, what'd you think? Oh, that was
Yeah. Homework cheating is 15, but 18 to 20.
tiny, nicely charged particles called the rest of the word. Very chocolate.
No, just 15 and then 18. Oh, what? Maybe I'll put 18 very quickly.
Yeah.
All the rest of this.
Yeah.
No. Oh.
Yeah.
And if you're not sure what to do on the practice quiz, pages 9 and 10 in your book have all the answers. Okay?
Yeah, it was just off for 8. That's what I'm doing. You're in. I did the same. Really? It was not the movies.